Welcome to a new episode of Drops of Science, the multilingual podcast that brings you the latest news and discoveries in the world of natural sciences. With today's episode, we are celebrating the second anniversary of this podcast, and continuing the tradition we started last year, we've prepared something different for you who continue to follow us and for those who have just discovered us. In this episode, we want to talk about numbers. What do they have to do with natural sciences, you might ask? Well, we want to tell you how many species exist, how many species existed, and how many could still appear on our planet, and understand why each one matters within the great web of relationships between organisms. But first, let's ask ourselves, how many life forms share Earth with us? Many more than we imagine. And to begin counting them, we need to clarify a starting point. How can the scientific community say, yes, this is a new species? So let's start with what we mean by species, a definition that's anything but simple. We have the morphological concept, according to which similar individuals belong to the same species, while distinctly different individuals belong to different species. This is how Carl von Linné, in the 1700s, the creator of the binomial nomenclature we still use today, described thousands of species. However, today we know that some organisms of the same species can be morphologically different. Think of dogs. Between a husky, a Great Dane, and a Chihuahua, the morphological differences are vast, and yet they all belong to the same species. For this reason, a new concept was introduced, the biological species concept, coined in the 1940s by Ernst Mayr. In this case, it refers to groups of natural populations within which interbreeding occurs, actually or potentially, and which are reproductively isolated from other groups. In other words, a species is a group of organisms that can successfully reproduce and produce fertile offspring. This led to dividing animals, plants, and other forms of life into groups based on their reproduction. Although this definition is still in use and is the most well-known, the one we are taught at school, if we start digging deeper, we'll still find problems. What about asexual organisms? How do we identify them? What about unicellular organisms? And according to this definition, hybrids play a key role. If they are sterile, that is a proof the parent species are different. But there are very different species that create fertile hybrids. Think about grapefruit, whose botanical origin is still not very clear. It is believed to be an ancient natural hybrid between pomelo, Citrus maxima, and sweet orange, Citrus sinensis. But for centuries, it has been an autonomous species capable of reproducing through grafting or cuttings. For plants, in fact, this biological definition of species is not very simple to apply. So how do we proceed in such cases? One solution can be the genetic species concept, where DNA, molecular markers, and other tools help us identify species, as in the case of bacteria. And we can add even more definitions, such as the phylogenetic species concept, where a species is one of the branches of the tree of life, the smallest group of organisms sharing a common ancestor and distinguishable from other similar groups. Or the ecological species concept. In this case, a species is a set of organisms adapted to a particular set of resources, called the ecological niche. According to this principle, it is the resources of a given environment that produce differences between species in form and behavior. Now you might be wondering which definition is correct. Unfortunately, it depends on the school of thought and what is being identified. A paleontologist, for instance, cannot use the biological definition of species. They will start with the morphological one and, if lucky, add the genetic information. After all, we can't exactly observe dinosaurs reproducing. What happens when we discover that what we have in front of us is, in the end, a new species? Then comes the naming, and for that we should probably dedicate another episode, perhaps about the funniest or strangest names. The fact, according to the binomial nomenclature, First used by Linnaeus, as already mentioned, the scientific name of a species is in Latin. This name is crucial because it identifies the species everywhere in the world, unlike the common name, which can vary not only by language but also by country. However, scientific names don't remain fixed over time. Thanks to scientific progress and new discoveries, a species can change its name. The specimen does not change per se, only the way we describe, in the most accurate manner, the relationship between organisms. This is where taxonomy comes in, a scientific system that classifies organisms into categories according to certain characteristics. Sometimes a species changes genus, sometimes the genus itself is split, so the entire binomial system changes, and often scientists debate for years whether to change a name or not. But all these definitions and names are what help us understand how organisms can be so different, yet also so similar. If we go back not only through historical time, but also our phylogenetic history, meaning the evolutionary history, we find that humans are part of the order primates, which also includes gorillas and lemurs. All these together are considered mammals, a class that also includes hedgehogs, whales, and bats. Going farther back, we reach the film Chordata, which includes all vertebrates, thus also reptiles and birds, but also lancelets and tunicates. Farther back, we all belong to the kingdom Animalia, which also includes insects, mollusks, and much more besides us humans. Can we go back even further? Certainly. We reach the domain Eukaryota, to which we belong with plants, fungi, and some unicellular organisms. Somewhere we are related to other living beings, but at the same time we are also very different. This diversity brings us back to the question posed at the beginning of the episode. How many are we? Giving an exact estimate of how many species exist on our planet right now is practically impossible. Not only because species names are constantly debated, but also because many living beings hide from scientists. They camouflage. They are too small, they live in inaccessible environments, and for many other reasons. But we can talk about what we know and then make estimates. For example, according to the IUCN Red List, the number of described species so far exceeds 2 million, considering vertebrates, invertebrates, plants, fungi, and protists. Of these 2 million, just over 76,000 are vertebrates. With mammals, we are just under 7,000 described species, about 11,000 birds, just over 12,000 reptiles, 8,800 amphibians, while fish exceed 30,000. The number of described plants is much higher, over 400,000. For fungi and protists, there is still much to be done. Only 162,000 species have been described, while invertebrates climb to over 1 million. But how many might there be? It is estimated that vertebrate numbers may increase, but not by much, whereas for insects, fungi, protists and bacteria, the numbers are staggering. More than 6 million fungi according to a 2021 study, and a 2023 study estimated that insects could exceed 20 million species. These numbers are even bigger if we think about the oceans, where researchers estimate that 91% of species remain to be classified, and that at least 80% of the oceans have not been mapped, nor observed or explored. All this richness of life does not mean we are safe. On the contrary, the more we study biodiversity, the more we realize how fragile it is. Of the species described today, or at least those given a name, many are endangered or potentially at risk of disappearing, either in the wild or completely, including those living in captivity. How many? Again, there are only indicative values, because they don't refer to the total number of species on Earth, but only to those we know. At least 70% of cicadales, an order of seed plants, are threatened. Reef-building corals are about 44% threatened. Similar values are found among amphibians, 38% among trees, and just below that, sharks, rays, and chimeras. just to name a few groups. And in the past, researchers estimate that about 99% of the species that ever existed on our planet have become extinct, which could mean that around 5 billion species have abandoned our planet, if we take conservative estimates, but there could have been many, many more. Most of the species belonging to this 99% perished in 5 catastrophic events, what are called mass extinctions. The first occurred about 450 million years ago, during the Ordovician-Silurian transition. Mass extinctions are the consequence of rapid, large-scale environmental changes that lead to the disappearance of a large number of species in a geologically short period of time, and the survival of others which will gradually repopulate the planet. The species that live on Earth today belong to the 1% that survive all these great mass extinctions, the last of which occurred about 66 million years ago, between the Cretaceous and the Paleocene. And, when we are lucky, we manage to find something of what remains of the past, in the form of fossils. If we think about how much there is still to discover, it is easy to imagine that some species are born, live and go extinct without leaving a trace, without humans ever having seen or described them. And of those we do know, paradoxically, the more we learn about them, the more we realize we are about to lose them. We began by asking ourselves how many species there are. As you may have guessed, the answer is that we don't really know. But we do know that each of these species, known or unknown, plays a role in the web of life, and that protecting them ultimately means protecting ourselves as well. Thank you for joining us for this special episode. We hope to see you again with our regular episodes and again in a year's time. See you soon, and good science!